Find the number of ways of forming a 4-letter or a 3-letter code word from the letters in the word shoot. So, the number of ways of forming a 4-letter code word from 5 letters, if all of them were distinct, would be fairly straightforward, right? We'd just take 5, permute, okay, so let's say I had shoot, but I had O1 and O2, so I could tell the difference between the two O's. Then the total number of ways of forming a 4-letter code word would just be 5 permutes 4. So arrange four of the 5 letters to form a word. The problem is that I may not necessarily or I can't actually tell the difference between the two O's. So how do I do this instead? Well, I split it into cases. I look at case 1, where I have one O in the code word. So what does that mean? Well, it means I've only got one O, so there's an O used in there somewhere, and that means I must use S, H, and T on top of that. So I now have 4 distinct letters to make a word from. That gives me 4 factorial ways of making a code word with one O. What about case number 2? Well, that would then be 2 O's in the code word. How do I do this? Well, if I've got both of my O's in there, I then have to take 2 of S, H, or T. So we'll learn this notation called 3 choose 2 in the next section, but it means from S, H, and T, from 3 letters, choose 2 of them to be in my code word along with the 2 O's, and then I would have 4 factorial over 2 factorial ways of arranging these 4 letters, and that is 36. So same way, 4 factorial is 24, so 36 plus 24 is 60. What about the second question? A 3-letter code word from the letters S, H, O, O, and T. Well, again, we split this up into cases. Case 1, no O's, right? So it's possible that I have no O's in my word. Well, then I must have S, H, and T, and that means I have 3 factorial ways of arranging those 3 letters, and that is 6. Well, what's case 2 then? Case 2 is 1 O. And so, what does that mean? It means I've got O and then 2 of S, H, or T. So again, we go from S, H, and T. I choose 2 of them to accompany my O. And I then have 3 distinct letters which can be arranged in 3 factorial ways. 3 choose 2 is 3. And that gives me 3 times 6 is 18. Case 3 is what? Means I would have 2 O's in my word. So I'd need to choose one of S, H, or T. So from those 3 letters, choose one of them. And then I have 3 letters, but 2 of them are the same, so 3 factorial over 2 factorial ways of arranging this. This is 3 times 3, this is 9. So in total, what do I have? I have 6 ways of arranging it with no O's. I have 18 ways of arranging it with 1 O, and I've got 9 ways of arranging it with 2 O's, so I have 33 possible 3-letter code words. And so this is exactly what I was saying earlier. Notice that when certain conditions are given, we satisfy these conditions first before selecting or arranging the other letters.